Okay, so I'm actually going to start with arc length and start with the way that you did it before. Okay, so arc length, you've seen problems like this.
Yeah.
You've seen problems where it's just, here's a circle, here's a part, how long is that, right? What information did you need?
The center, or the radius.
You need the radius and the angle. So the first group said we need the circumference and the proportion of the circle that it is. These are the same, right? If you have the circumference, you can get the radius. If you have the radius, you can get the circumference. It's the same information. If you have the angle, you can get the proportion and vice versa. So either way, those are the same things. So you need both of those. So I'm going to give you both of those. So the radius is 5. The angle is 93.5 degrees. So calculate for me the arc length, not out loud, on your board. Okay, so we have some who remember this and some who don't. And basically, it comes down to this. Question 1, what is the circumference of the whole circle? What's the circumference?
935 pi.
2.6 pi.
Alright.
Just the circumference. So what's the formula for circumference?
Pi d.
Yeah, diameter times pi. So what's the diameter? So what's the radius, the circumference? 10 pi, right? So we have 10 pi. You get a pen. Okay, so the entire circle is 10 pi. How do I know what portion of the circle was represented by the arc?
The degree over 360.
Yeah. We had 93.5 degrees, so 93.5 360ths, right? Because there are 360 degrees total. So we have 93.5 360ths of 10 pi. And then once you got that, some of you left it, so would I have. Some of you put it in your calculator, got a decimal. That's fine. But was this an enjoyable experience for anyone?
Yes.
There are always a few who say, so I think there are a few who say yes because it's true, and a few of you say yes because you think I want you to say yes, and then the rest of you say no, clearly it was not, it was tedious, right? Huh?
This is fun. Radians are better.
But we're not to radians yet. This isn't.
Radians are...
They're rad.
No, they are not horrible. You will learn. You will learn.
I don't like it.
Okay, here's a question for you.
Because it's too high.
Why are there 360 degrees in a circle?
Because of tau. That's it.
No.
I think so.
No, because we just decided it.
Okay, somebody just decided
Did we
it.
decide or wasn't it like, doesn't it involve our rotation around the sun?
It does.
It was
So, yeah. So there are 3 different ways things happen in math. One is things that naturally feel like they must be so, right? So if A is less than B and B is less than C, then A is less than C. We just believe it in our hearts and we call it an axiom. So there are things like that that just kind of have to be so. There are things that we define so that other math doesn't break. So our rules about exponents all work well up until the point where you have something to the 0, and the thing that makes something to the 0 not break the rest of math is to make it 1. Okay? So that's why we do that. And then there are some things that somebody just went, let's do this. And in this case, it had to do with the sun. You're the first person that's known that all day.
We're the
Okay.
Mesopotamians,
So-
Sargon, Hammurabi, Ashurbanipal, and Gilgamesh.
So long ago, they looked at the sky all the time. And they counted all kinds of things, they measured all kinds of things. And so they looked at the rotation of, they may have thought it was the sun around the earth, but it didn't weigh the rotation, right? Can you hear that though? That's lower, that's the rotation of the earth right there. That's from NASA, isn't that cool? Okay, so they measured this, and they came up with 2 things. One, they decided it was a circle, and you know it's an ellipse, but if you actually graphed it, you would see, like, you can't tell the difference. It's so thick an ellipse it looks like a circle. They decided it was a circle, and they also decided it was 360 days. That's what they calculated. So is that correct? No, it's super close. It's impressive, right? Because it was a long time ago. It's really, really close, but it's not correct. But what they said was, okay, we've got this circle, and this circle goes around every 360 days. So every day is 1/360th. We'll call it a degree. So we've got 360 degrees. So this really is the case of we decided so because of this false thing we believed.
So circles should actually be 365 degrees.
0.25, right? Like it's not even exactly. Yeah, so it's not an ideal way to do it anyway. It made sense to them. They were busy calendaring, okay? But there's another problem. So you guys are going to be in calculus next year, and I don't actually know that if you get to calculating arc length or not, but if you use calculus, and calculus is one of those things that it must be this way. Like the way it functions, if we live in these 3 dimensions on this planet, that is what works, okay? So that wasn't Isaac Newton decided. It's the way things work. It measures, and it measures accurately. And if you measure around the circle using calculus, you end up with the radius times the sum total of the angle. So if I have a circle with unit 1 radius, then I would get that it's 360 around, which is certainly not, right? And you have the degree units, so you can kind of like fix it, but it's a beating, and it doesn't work right with calculus, which is why all your physics formulas were hideous and had pi's in them. Okay? So, if we're thinking about circumference, and we're thinking about it from the perspective of the first people trying to sort out circumference, hundreds of years are passing now from the 360-degree debacle.
We're the Mesopotamians, Sargon, Hammurabi, Ashurbanipal, and
It's a
Gilgamesh.
great song. Okay?
I thought it was someone's
Yeah, me too.
No.
I thought it was a ringtone.
No, Mesopotamia, see, it was Sumerians, and now it's Babylonians, separated in time in Mesopotamia. And I've got their little buildings to show they're more advanced. Okay, because all this time's passed. So the Babylonians, now we've got a 24-hour day. That's kind of been decided. They're still working on calendars, but they also kind of want to know about circles and circumferences. So they're trying to figure out the relationship between a radius of a circle and the circumference. You guys think of it as the relationship between diameter and circumference, right? Because it's diameter times pi, and pi only has a name because it does that job, right? But why would you consider, if you're a person back in this time and you've never seen a formula for it and you're thinking about circles, why would you think about radius instead of diameter?
Probably involving shadows from the. Because isn't that how
Could
we
be.
first started using time? We would measure shadow length.
Yes. Yeah.
Center of the circle.
Yeah, it's from the center, so I hadn't thought about it that way. So that's an interesting point, too. One thing is they probably did care about, someone brought up earlier, the distance from the Earth to the sun, right? And that's a rotation around, so you're looking from the center. But just generally speaking, out in the world in nature, if you're trying to make a circle or even with a compass on your paper, you start with a center and you spin something around it, right? So the length of what's being spun is kind of what makes the circle what it is, along with the center. So they were looking at the radius. They wanted to compare the radius with the length around. Okay, so they're looking for connections. But they know that they can use polygons. Polygons have long been used to approximate circles because just the more sides you get, the closer to a circle you are, if it's a regular polygon, right? But because they wanted to know radius to edge, they started with an equilateral triangle because the radius is the edge, right? So far it's straightforward. Radius 1, edge 1, or 3, 3, or 5, 5, whatever, but they're the same. So then if you put them all, then they would approximate the circumference here as 6 times the radius, right? Because I have 1, 2, 3, 4, 5, 6 little radii running around. So that was their approximation. So this to them was relevant because the angle here should be, to them, the angle that approximately yields an arc length of radius, of 1 radius, okay? So if you're doing that, and you have 6 of them, and there's 360 degrees total, then how many degrees are in one of them?
60.
60, because
360.
360 divided by 6. So they got this 60 degrees, and so now we have 60 minutes in an hour, and 60 seconds in a minute. Because 60 is fancy, and it does things, right? They used base 60. Just generally. So the Babylonians, base 60. Do you guys know what base our number system is? 10. Do you know why it's 10?
Because 10 fingers.
10 fingers, right? So we start counting this way, so we're base 10. The Simpsons would be base 8, presumably. So they used base 60. And so far it seems like they're doing a lot of things wrong, right? They did a lot right. They could really measure. They could measure the distance between two things which were far away from each other and far away from them, using information from where they stood. They were really good at using math to measure. So let's go back to what they wanted to do. What they wanted to do, remember, was find where the radius, the angle, so that the radius and the edge were the same. So if we do that, here's a radius, here's an edge. They're the same. So then the question is, well, but the radius is 5 and the edge is 5. So the question is this angle right here, right? We've not gotten there yet, Alex. Okay, so I'm going to put back the unilateral triangle, equilateral triangle. I lost word power a long time ago, I'm sorry. Okay, so if this is the angle, so that this is 5 and this is 5, then this is 60, right? That's what they did. Is this arc bigger or smaller than 5? It's bigger than 5. So if I want the arc to be equal to 5, should I make the angle smaller or bigger? Smaller, because I want to get that arc smaller. It's 57 point something degrees, but at any rate, what we did was we named it. The angle, so that the arc length is 1 radius, is a radian. Okay? So radian measure. Okay, so supposing that the radius is 5 and my arc length is 10, what is the degree measure, or the angle measure, sorry? 2 radians. Why?
Because
It's 2 5s.
It's 2 5s. 3, because it's 3 5s. Why do you think it says theta instead of x or a or b or whatever you've named them in the past?
it's the standard.
Yeah.
It's tradition.
Tradition. So Greek typically implies that we're doing radian measure. We start with theta, but sometimes theta is busy, and then we use alpha, beta, gamma, or whatever, but it's Greek, typically. Okay? So now this is the same question as before, right? We've got this red part. What's the red part? So you still need to know radius, angle. Those are still the 2 pieces of information you need, right? Give them a name. What are you going to call your angle? Like write down angle equals blah, name it. Radius equals, and name it. Okay, so now that you have them named, I'm going to tell you that the radius is 7 inches and the angle is 1.45. And now I want you to calculate the arc length of this. Okay, so if this had been 1 radian, what would the arc length have been? And if it had been 2, it would have been,
14.
which you got by doing what?
Yeah.
Yeah. Multiplying theta times 7.
Yeah.
So 1.45 radians, the arc length is,
10,
which you found by what?
multiplying.
Right, but multiplying 1.45 by 7, which you got by math, yes. Okay, so I'm flipping it a little bit now. I'm giving you the arc length, and I'm giving you the radius, and I'm asking you for the angle. We had the angle and we had the radius. What do we do?
Multiply.
We multiply to get this. So if I want to unmultiply, now I have to divide. So
It's just it's a
7
different
times
system.
whatever this is 9.6. So 9.6 divided by 7 is this. Right? We want to know how many 7s is 9.6. Because that's what a radian measure answers. Right? How many radii are there? Okay, what if I instead tell you, okay, you've got 1.56 radian, and you've got 9.6 is your arc length. Okay, so, what is the radius? And how'd you get 6.15?
Divided.
Okay,
9.6.
so what is the relationship between, so remember you named angle and radius, and if you didn't name arc length before, name it now.
It's like a.
And then write down a formula that shows the relationship. You only need one formula because you can rearrange for the rest of them. So write down a formula that relates whatever you named angle, whatever you named radius, and whatever you named arc length.
Just about a half.
Okay. So what's the relationship?
Arc equals radius times angle.
Yeah, arc length equals radius times angle, right? Standard notation is this. Some places will write out arc length, in part because capital L is also used to mean limit. But this is the formula, right? So, 2 questions now to answer is, what's the relationship between radians and degrees? And did we solve our calculus problem?
So radius times 180 over pi.
Yeah, times 180 over pi. Let's get there doing the calculus problem solving issue, okay? So let's answer this one first. I guess I could have written them in the other order, but I did not. Okay, so suppose that I have, it's a terrible circle. I'm just going to erase it. It's so bad.
I'm so confused. I'm so good
It's, this ends suddenly, and then you have to go back. I thought there was a way to erase it. Well,
Just reset it. No, just go with it. Just go.
okay.
It's
It's shading. Okay.
It's not even close.
Okay, so I'm going to put this, and I'm going to say this whole way around, this is theta. Okay, what do you want the radius to be? 10. Okay, so based on how we defined a radian, the circumference should be equal to 10 theta, right? Because that's how we define it. What is the circumference of this circle?
25.
20 pi, right? So radius is 10. The diameter is 20, so 20 pi. So then 10 theta equals 20 pi. What's theta?
2 pi. Tau.
Theta is 2 pi. Now if I say that a unit circle, so radius 1, is equal to 1 times all the way around 2 pi, does this now function properly? It does, because it should be 2 pi, right? So that's fixed. So now we have the relationship is 360 degrees is 2 pi, which one of you already simplified is to say 180 degrees is 1 pi. That's dividing by 2. So we've got 2 pi is 360 degrees. Pi is 180 degrees.
Neil, scoot an inch to the left.
That's right.
Okay?
I was about to say my right.
So both of these are valid relationships to state. Okay, so if 2 pi radians equals 360 degrees, what are the unit change factors? Do you remember unit change factors?
Factors that change.
That change units? They are. It's true. They're factors that change units. Okay, if I have an equation, I can sort of multiply by anything I want but 0, right? Add anything I want to both sides. But if I just have a thing, I can't do that. I can multiply by 1, I can add 0, and these are my only options, right, to not mess with stuff. So, let's say that you had 231 inches, and you wanted to find out how many feet that is. What would you do?
12 multiplied by the factor.
Yeah, so dividing by 12, multiplying, you're really multiplying by a unit change factor. So you want to get rid of inches, so you want inches in the denominator so they cancel out. And you want to have feet, so you put feet in the top. But this has to equal 1, or I can't multiply by it. I can't just go around multiplying by stuff. So how many feet is how many inches to make 1? 1 foot, 12 inches. Could I have put 5 feet and 60 inches?
Oh yeah.
Sure, but it would just simplify out, right? It'd just cancel out. Okay, so this right here is a unit change factor, and it makes the inches cancel, and that's what you wanted. So you think, oh, I divide by 12, but you're really multiplying by this. And if you wanted to go from inches to miles, you would change it again now, right? So that's a unit change factor because it's equal to 1 and it changes the units. So what is it if I had 57 degrees and I wanted to know what it is in radians? What unit do I want to cancel? Degrees, and the one I want to get is radians. So what can I put here? Pi and 180. Or 2 pi and 360. Okay? What if instead I had 1.9 radians and I wanted degrees? So I want radians down here so they cancel, degrees up here, 180 pi. So these are the unit change factors. Does it make sense? Do you guys have any questions about this part? Am I out of time, or are you moving gradually toward the door because it's time?
No, I'm moving because I need to go get the flags down.
Oh, yes, please do that.
Thank you.
Oh,
it's almost
day is nearly over.
They're still getting rained on them.
84.
Okay,
It's Radian?
convert 270 degrees to radians. Either simplify the fraction, or if you put it in the calculator, round to 2 decimal places.
With your middle finger.
Okay, so I think I'm essentially out of time, but guys, some of you were thinking, oh, I've seen the unit circle before and this was 3 pi over 2. Just real quick. So we would take the 270 degrees, we multiply by the pi over 180 degrees because we want to cancel these. 27 over 18 is 3 halves. I'm off the page again. 3 halves pi, and then you've seen it written this way, right? So this is why those are the same. Okay, enjoy satellite.